In this lesson, we are going to see how to choose the optimal model using training data only. So, optimal model selection is useful in best subset forward selection and backward selection to pick the best model there. And you know that these models each result in a set of models with a subset of the p predictor variables. As we discussed earlier, we are interested in finding a model that has a low test error. Note that the obtaining smallest SSE or the highest R squared for a model on the training data is not helpful for prediction purposes. So, there are two ways to select a good model as far as test error is concerned. One is make adjustments to the training error to deal with bias from overfitting, or use cross validation on the test data, and we are going to discuss cross validation in another module. We know that the mean squared error is given by that expression, and typically this is an underestimate of the test set mean square error. So, we can use these metrics CP, AIC, BIC or adjusted R square to adjust for training errors. So, one approach to adjust for training error is to use CP. So, if a fitted least square model has D predictors, the CP estimate for the test mean square error is this. So, where sigma squared is an estimate of the variance of the error for a model using all predictors. So, essentially what we are doing here, we are adding a penalty term to the training SSE in order to get the value of CP. So, for models with a low test error CP, CP is usually very small. Given a set of models to consider, we choose the model that has the lowest CP value. There is also AIC and BIC, and if the models are fitted with maximum likelihood, then the Akaike information criteria AIC is used, and that has a formula given that, which is very similar to CP with a slightly different penalty term. And there is BIC, which is the Bayesian information criteria, is from a Bayesian perspective, which is very similar to CP and AIC, and the formula for that is given here. Just note that BIC usually places a heavier penalty, or its penalty becomes larger than AIC for models with large p, since log of n is greater than 2 when n is greater than 7. So, given a set of models that we need to consider, we choose the model which has the lowest AIC or BIC value or lowest CP value. Adjusted R squared has already been discussed in the module on linear regression. In this lesson, we saw how one can adjust the MSE obtained from fitting the training data to select the best model for the test MSE.